Assalamualaikum warahmatullahi wabarakatuh. Hello all. I will introduce myself. My name is Muhammad Hafiz Muhajir and my name is 191440026 instrument 2A. In this section, I will to explain about level measurement. What is level? Material level in a tank or vessel is common process variable in plants. We measure level for filling control, for inventory control, and for providing safe operation to personnel and equipment. Level is often measured in percent of spend, but may be displayed in engineering units of feet or inch or even pound if the tank geometry and material density is taken into account. Level measurement technologies can be placed into one of two groups, contact and non-contact, and level sensor in each of these groups can be of the continuous or points variety. Points and continuous level. Point sense level probes only sense tank level at discrete level. Point sense probes are typically used for high or low level sensing to prevent plant personnel and or process equipment from being exposed to harmful conditions. Point level probes are also used in paints in process in which we do not particularly care what the exact level in a tank is, only that it is between 2 points. Continuous level. Continuous level probes sense the tank level as a percent of span of the probe capabilities. Continuous level probes are typically used where we need some type of inventory control, where we need to know with some degree of confidence what the particular level in a tank is. Common level sensing technologies is non-contact level measurement and contact level measurement. Non-contact level measurement is ultrasonic meter, radar types, and nuclear level sensor, but contact level measurement is pressure types, RF capacitance, and guided wave radar. First, ultrasonic meters or USM. Ultrasonic meters use of sound waves in the 20 to 200 kHz range, above the range for human hearing. A transducer mounted in the top of a tank transmits sound wave in bursts onto the surface of the material to be measured. Echoes are reflected back from the surface of the material to the transducer, and the distance to the surface is calculated from the burst echo timing. The key points in applying an ultrasonic transducer are: the speed of sound varies with temperature. Number 2, heavy foam of the surface of the material can absorb the sound wave bursts, resulting in no echo or an echo that is too weak to process. 3. An irregular material surface can cause false echoes, resulting in irregular readings. 4. Heavy vapor in the airspace and can distort the sound waves, resulting in false reading. 2. Radar types or microwave. Radar or microwave level measurement operates on similar principle to ultrasonic level probes, but instead of sound waves, electromagnetic waves in the 10 GHz range are used. When properly selected, radar can overcome many of the limitations of ultrasonic level probes. Rather can 1. Be unaffected by temperature change in the tank air space. 2. See through heavy foam to detect the true material level. 3. See through heavy vapor in the tank air space to detect true material level. Number 3. Nuclear level types. Continuous nuclear level detection is typically used where most other technologies are unsuccessful. Different radioactive isotopes are used based on the penetrating power needed to pass through the tank. Radiation from the source is detected on the other side of the tank. Its strength indicates the level of the fluid. Point continuous and interface measurement can be made. Now we are going to part of contact level measurement. In the contact level measurement, number 1 is the pressure type. Measurement of level by pressure release on hydrostatic principle. Pressure is a unit force over a unit area. A cubic foot 12-inch length, 12-inch wide, and 12-inch height of water weighs 6.4796 pounds. The area that a cubic foot of water occupies is 144 square inches. Therefore, a cubic foot of water exerts a force of 6.4796 pounds over 144 square inches, or 0.4339 psg for a 12-inch water column. It would not, no matter how many cubic feet of water were placed side by side, the pressure would still be 0.4399 psig. Hydrostatic pressure is only dependent on the height of the fluid, not the area that is covered. 2. RF capacitance or resistance. RF or radio frequency capacitance level sensor make use of electrical characteristics of a capacitor to infer the level in a vessel. Capacitor is essentially two metal plates separated by a dielectric or insulator and acts as a storage vessel for electrons. The size of the metal plates, the distance between the plate and the electric filling the space determine the capacitance value, or how many electrons can be stored. In a RF capacitance probe, one of the metal plates is the tank wall, the other metal plate is the sensor probe, and the electric is either air, or where the tank is empty, or the material in the tank. 3. Guided wave radar. Guided wave radar is similar to the non-contact radar probes, only a rod or cable is immersed into the material like an RF capacitance probe. The rod or cable is used to guide the microwave along its length. Where the rod or cable meets the material to be measured, a wave reflection is generated. The transit time of the wave is used to calculate level very precisely. Unlike an RF capacitance probe, A guided wave radar probe can measure extremely low dielectric material. Thank you for attention and see you.